Okay, this is a question from chapter 27, fundamental problems. It asks us to find the flux, the magnetic flux, given that being the magnetic field, and it's for these two surfaces. So what surfaces are they? It's this surface here and this surface in the back that's like that, and then the one that's at an angle. So what do we do? Well, for the surface A, B, C, and D, well, okay, no, first let's establish the flux, right? Let's establish which way that magnetic field is going. The magnetic field is going this way. Okay, now when the magnetic field or the flux, the magnetic flux is equal to the magnetic field times the area of the surface that it's going through. If the magnetic flux if the magnetic field and the surface are perpendicular to each other, like for example, ADFE, this one in the back, it's perpendicular, that means that you can just leave it as B times the area. If there's an angle, then your flux is BA times the cosine of theta. So that you use cosine of theta when it's not perpendicular to when the surface is not perpendicular to your magnetic field or the movement of your magnetic field. So I calculated my angle of incline, which would be this one right here. This is the angle that's going to come in here, right? Because that flux is hitting it at that angle. So now what's going to happen, this is that, right. So now the flux on ABCD, which is this inclined one, is my magnetic field, 0.8 times my area, 3.5 times 5 meters times 3.5. And that's going to be, times the cosine of my angle, 3.3. That's going to give me 8.14. Then for the one that's perpendicular to it, it's just your magnetic field times your area, and that's 14. That's the maximum that you can have.